A couple of problems from section 6.3. Okay, let's see. Whiteboard. We have tangent of theta. Tangent of theta equals to -3/4. And we are told that cosine of theta is greater than 0. Now, that's very helpful. So we know that cosine is positive in quadrant 1 and in quadrant 4. And if tangent of theta, which is sine of theta over cosine of theta, is negative, so I have to be in quadrant 4, because in quadrant 1, tangent is positive, because sine is positive and cosine is positive. So if I draw a triangle, a right triangle, that, and this is my, in quadrant 4, so let me pretty much something like this. Here's the theta, and here's the 90 degrees. Well, we know that tangent is opposite or adjacent. So opposite, since we decided I'm in quadrant 4, and adjacent is 4. Okay. Well, using Pythagoras, this is, 5. A squared plus b squared equals c squared. So this is the famous triangle, 3, 4, 5. So the question is asking to find sine, cosine. Well, so let's see. So sine of theta in this case is opposite over hypotenuse, so -3/4. Cosine of theta equal adjacent over hypotenuse, so 4/5. Tangent of theta is given. Let's talk about cosecant of theta. Cosecant of theta is 1/sine of theta. You can think of it that way. Or you can think of that as hypotenuse over opposite. And that gives me -5/3 for, cosecant. Cosecant of theta. Cosecant of theta equals -5/3. What else do we need in this problem? Let's see, secant of theta. Secant of theta, which is 1/cosine, or you can think of it as hypotenuse over adjacent. So cosecant of theta equals to 5/4. And finally, cotangent of theta. Cotangent of theta equals cosine of theta over sine of theta. Or you can think of it as 1/tangent of theta. Or you can simply think of cotangent of theta is adjacent over opposite. And that gives me -3/4. -3/4 for cotangent of theta. Let's do one more. Okay. We have I think this one is number 48. So we have secant of, this is given, secant of theta equals to 5, and sine of theta is smaller than 0. What do we know about cosecant? About secant. You know that secant is 1 over cosine. So if secant of theta is 5, which is 5 over 1, then cosine of theta is 1 over 5. Okay. And we know that since cosine is positive and sine is negative, again, we are thinking in quadrant 4. So I do have, let me change the color. I have, let's put something like this. So here's my 90 degrees. Here's the theta. And cosine is adjacent or hypotenuse. And let's see, let's figure out that I have 5 squared equals to 1 squared plus this side, let's call it, you can call it b squared, I suppose. So b squared equals to 24, and b equals to square root of 24, which is 2 root 6. And you have, remember that this in quadrant 4, this value right here is negative. So negative 2 square root of 6, negative 2 root 6. So let me give myself a little bit of room in here. And so here is the triangle. So this is minus 2 root 6, 5, and here's 1. Okay, what is sine of theta? Sine of theta is opposite or hypotenuse, so I have minus 2 root 6 over 5. Cosine of theta, we already have it. Tangent of theta equals opposite or adjacent, so negative 2 root 6 over 1, which is negative 2 root 6. Okay. Cotangent is 1 over that, 1 over tangent. Cotangent of theta equals to 1 over tangent of theta, so that's going to be minus 1 over 2 root 6. And if you want to rationalize the top and bottom and multiply top and bottom by root 6, that equals to negative root 6 over 12. Oops, 12. Okay. So we found secant was given, cosine, sine, tangent, cotangent, and how about cosecant? Cosecant is 1 over, give myself a little bit of room in here. Cosecant of theta equals 1 over sine theta, so that equals to 5 or negative 5 over 2 root 6. We can rationalize the numerator, the denominator, but really doesn't matter at the moment. Okay, let's do one more, just for the sake of discussion. Suppose we know, let's see, let's do number 50. Number 50, we have cotangent of theta equals to 1/4. And we know that sine of theta is smaller than 0, so that's negative. Okay, sine is negative in quadrant 3 and 4. But cotangent is positive, which is like, cotangent is positive in quadrant 1 and quadrant 3. Well, quadrant 1 we can't have because sine is, we know that sine is negative. So I have to be here in quadrant 3. Okay. So let's draw a triangle. Pretend this is a nice right triangle. What is it that we know? We know that cotangent is 1/4. So you probably think to yourself that, wait a minute, both here in this triangle, in quadrant 3, sine is negative and cosine is negative, and that's what it is. So I have this as -1 and -4 in quadrant 3. So what's the sign of hypotenuse? A squared plus b squared, square root of that gives me square root of 70. All right, and remember that theta is here. Theta is always attached to this origin. All right, so what is sine of theta? Opposite over hypotenuse, -1 over opposite, -4 over 17, square root of 17. Which is the same as saying -4 root 17 over 17. What is cosine of theta? Cosine theta is adjacent over hypotenuse. So I have -1 over square root of 17, which is same as minus square root of 17 over 17, rationalizing the denominator. Tangent of theta, which is opposite over adjacent, -4 over -1, which gives me just the negatives cancels out, 4 over 1, which is a 4. And we also knew that tangent is 1 over cotangent, as cotangent is 1 over tangent. So I really didn't have to do any work for that one. Secant of theta, let's do cosecant of theta. Cosecant of theta equals 1 over sine of theta, so minus root 17 over 4. And finally, what is secant of theta? Secant of theta, which is 1 over cosine of theta. Okay. Let's see if I have square root of 17 over -1, which is minus root 17. Okay, that's good enough. I hope you like these examples. Thanks.